Hello everyone, I am happy to present you my research on fairness in machine learning in the perspective of sociology of statistics. My name is Bilel Benbouzid. I am professor of sociology at Gustave Eiffel University in Paris. I think many of you know this famous quote from John Rawls in Theory of Justice. Justice is the first virtue of social institution as trust is of system of thought. For those participating at FACT, this famous analogy may sound strange. Predictive machines are both social institutions and systems of thought. In the domain of fairness in machine learning, or fair ML as I will call it here, the values of justice and trust don't correspond to a logic of similarity of form. They are intimately connected. This connection of justice and trust is a raison d'être of my interest for fairness in machine learning as an object of sociology of statistics. Fair ML is not just a case among others for sociology of statistics. It is a place where we can observe contemporary transformations in the politics of statistics. Let's take this important contribution in sociology of statistics from Ted Porter's book. To become trustworthy, classically experts in quantification sought to eliminate any trace of politics from their measurement tools, excluding judgment and struggling against subjectivity, the pursuit of mechanical objectivity, as Ted Porter said. Since the 19th century, the development of statistical practices has been driven much more by the value of neutrality than that of trust, as Ted Porter has shown. But fairness in machine learning, and especially the fact conference, is making the mechanical objectivity not relevant anymore. What I will show you here is a kind of objectivity and epistemology behind the field of fairness in machine learning. The book of Daston and Gallison on the history of form of objectivity is very important for us. Daston and Gallison observe that mechanical objectivity involves an instability. Why? Because it is difficult to generalize from a mechanically generated case. It is impossible to exclude all subjectivity from scientific production. They observe an alternative to the mechanical objectivity. To capture specific dimension of particular phenomena and explain related scientific facts, experts use stylized illustrations. In your case, we will see the causal diagram is a good example of this stylized illustration. Subjectivity, or it is better to say interpretation, is not eliminated. Rather, the detection of relevant features requires the trained ideas of the experts. This alternative to mechanical objectivity is called trained judgment. In the field of fair ML, we observe a tension between these two different forms of objectivity that entail an epistemological problem: the improbable coexistence of the metrological realism of statistics and the constructivism of the social sciences. This difficult coexistence is analyzed by Alain Desrosières in his wonderful book on politics of large numbers. Fair ML is an important time in the history of quantification. It involves data scientists taking a de facto constructivist posture against metrological realism. As everybody knows in fact community, fair ML researchers are interested not only in what the quality of a prediction says about the relationship between the machine and reality, but also in what the machine is doing to reality by generating more or less fair decisions. How does this de facto constructivism regarding fairness in machine learning manifest itself in concrete terms? And what are the ethical effects of this de facto constructivism on artificial intelligence? Let's begin by socially localizing the formation of fair ML. Three researchers are most often presented as the pioneers of research on fairness in machine learning: Ellen Nissenbaum, Cynthia Dwork, and Tatiana Sweeney. These three researchers show how three different epistemic virtues, in the sense of an epistemic responsibility, can coexist and interplay: open-mindedness toward philosophy, rigor in mathematical reasoning, and a kind of political engagement. Epistemic virtue is a very important concept. No ethic of AI without epistemic virtue. Ethical AI can't just be an ethical statement in an ORIPS paper. It is a technology of the self. as Michel Foucault said, that change the nature of knowledge itself. This is these virtue ethics that have changed the meaning of bias. In FML, bias are becoming a scientific problem of normativity. Algorithmic decision has to do not with the rigor of data collection, but with the system's perspective on the world in the sense of the narrow standpoint. It is simply impossible to produce a neutral decision system. And for the user of these systems, bias is a problem in moral philosophy that arises in relationships to souls, human or not human, who are computed. How does this process of formalizing the political role and nature of algorithm works in practice? Studies on fairness in machine learning are generally divided into three broad groups of approach: group fairness, individual fairness, or causal fairness. Most epistemic reviews in the literature pit this against each other in a table. For example, the book of Baraka and Collaborator. Sometimes philosophers try to associate these metrics with a particular theory of social justice. I think this representation of the field does not explain the specific epistemology and ethical problem of machine learning. The field should instead be seen as an interactive component in a dynamic of controversies, where each approach brings a more an interpretative logic to the fore. I propose in the paper an alternative representation of the field by tracing the history of specific debate over the past decade. I propose two axes. The horizontal axis of associations means the associations of new conception of fairness. And the vertical axis of substitutions means simply the substitution of the previous proposition. I trace a front line of research where we can see that the drive to automated morality is pitted against the quest for the experts' trained judgment based on an ever more political sense of quantification. I will show you how methods for integrating fairness into predictive machine have become more progressively less automatic. First of all, the controversy begins with the moral economy of group fairness. Calibration and demographic parity appears as two good solutions. I don't have time here to explain these metrics, but just keep in mind that for many engineers, calibration was a good convention based on the engineering value of modeling efficiency. And demographic parity was a good convention based on the legal conception of fairness because it shapes algorithmic decisions in the direction of compensation in an unfair society. Maurice Hart, one of the most influential researchers in the field, has argued that these two metrics are not a good means to reduce fairness. He proposed the equality of opportunity metrics not only for mathematical reasons, but also for political reasons. Calibration cannot be considered as a social justice intervention because it is just a means to improve the performance of the machine. Statistical parity can be seen as the very opposite of fairness because it involves a form of affirmative action that is not rooted in any meritocratic principle. He proposed equality of opportunity as a better means to reduce fairness because it is task-specific, thus involving both the modeler and the user in understanding and refining the models. The argument of Hart is in favor of more intervention and less automatization. But group fairness is formulated at an aggregated level, and it has been shown that this aggregation can produce a form of fairness gerrymandering, regardless of metrics. Group fairness can result in discrimination against subgroups that lie at the intersection between different protected groups. It is a problem of intersectionality. Avoiding subgroup discrimination brings us to the level of the individual. Dwork was the first to propose an individual fairness metric to prevent such phenomena. Individual fairness is no longer calculated based on membership in a category, but by measuring an inter-individual distance. This metric is of interest to researchers because it is agnostic about the meaning of similarity, which allows it to be specific to each task. The main argument for individual fairness is still politics. Work justifies this approach by citing the procedural nature of individual fairness. Individual fairness approach requires making strong assumptions about the relationship between the choice of features and the classes to be predicted, which is not a trivial task for the modeler. To address this problem with individual fairness metrics, a counterfactual equity matrix is proposed. It is a causal approach that is presented as a natural way to define a similar individual. This metric is based on the intuition that a decision is fair to an individual if the same decision would be made in a counterfactual world where the individual belongs to a different demographic. The causal approach is motivated by the idea that issues of justice and discrimination are causal in nature, and that in order to develop algorithms that correct patterns of injustice, we need to look for the causal underpinning. It stands in opposition to the positivism of machine learning, which is not concerned with causal explanation. Then causal approach can be seen as another effort to give an increasingly large place to interpret. The dynamic of controversy in FML did not end here. Some critics of causal inference use a critical examination of the meaning of the category that are used in modeling. To manipulate social categories such as gender and race in a counterfactual analysis is to treat them as things in themselves, and thus to take a realist position again on social categories. Some scholars have called for the adoption of a more constructivist vision of social category in puzzle model, in order to take into account their social consistency. It is a Lilihu and Isaac Kohler-Osman proposition, constitutive diagram. It is one more step to conventionalism. But I think the controversy is not closed. You and Kohler-Osman ontology of the social and ontology of relationships remain a realist one. They treat social category as conventional, but the relationships that those categories create are taken to pre-exist the constitutive diagram and to have an entirely real existence of the world. This is why there is room for other, even more conventionalist approach that give more room to intervention and interpretation. I think the controversy can evolve toward the integration of increasingly plural formulation of the social into AI system. Then to become scientific, paradoxically, machine learning must progressively turn its back on realist conception of quantification. It must relinquish any aspiration to optimize for fairness outside the bounds of situated knowledge in the sense of Donna Haraway. To conclude, I would like to mention the comment of one of the reviewers. After reading this paper, I am still left wondering, so what? While fact may be an interesting case study for scholars outside your community looking in, I struggle to understanding the category is for fact. I am totally agree with the reviewer. What I am saying is obvious for the community of FML, but everything is obvious when you have the answer. At the end of the comment, the reviewer found himself the response at his skepticism about the interest of the sociology of statistics. So, the reviewers say, there have been countless papers making this point, seeking to bridge the social and the technical within the field. So, what does this paper analysis of this tension within this community offer researchers in the field? Or maybe another interesting question relating to this paper is, how has the highly interdisciplinary nature of fact enabled the improbable coexistence of the metrological realism of statistics and the constructivism of the social science? What does this unique coexistence have to offer broader computing fields? This is exactly the kind of question I wish to open with this modest contribution to the social epistemology of fair. Thank you very much for your interest.